Thank you very much. Glad to see a lot of people today. I will talk about something that we started like years ago, and then the things was actually growing. So I will talk about our approach of solving the problems of CVE and vulnerabilities collections, and then you'll see that some of the projects come. So I'm actually working at CIRCL, but in addition to that, we have an initiative called GCVE, and I will talk about that in the project. So what is the origin of Vulnerability-Lookup? It's very straightforward. So the project is run by us. It's co-funded by our own funding. We have some additional funding from the European Union. The software is actually used by us, so we have a public instance that you can use. There are many other users actually using Vulnerability-Lookup. And nowadays is indeed a reference implementation to the GCV standard, and I will come back to that later on. So if you are curious on the website Vulnerability-Lookup, you'll get a lot of details, and including links to the existing instance. So if we go back to the history, so I was co-maintaining and I was one of the core developers of CVE Search in late 2012. So the name says it was basically a local database for CVE management mainly. A lot of organizations were using CVE Search. Maybe some of you use it for various things, pen testing, security management, whatever. But over the time, we have seen that the tool that we developed was become limited for two main reasons. One was the actual usage. So CVE Search was the expose interface on cve.circle.lu, and we had around 20,000 queries per second on the public interface. So we had some limiting factor there. But I think the most important thing that we have seen over the past more than 10 years, it's the vulnerability sources have really diversified. So really, you have much more sources nowadays, and the NVD-CVE sources was not the single one, and that's why we started Vulnerability-Lookup, which is basically a rewrite of CVE Search to support that. So what was the initial challenge? It's the volume of data. So if you look at the different data set of vulnerabilities nowadays, and it's just a tip of the iceberg, you have more than 1 million security advisories. We are currently collecting close to 100,000 sightings. And we wanted to have something that is super flexible because, you know, world is changing. We might have new sources, new vulnerabilities, complex. It's sometimes very chaotic. You might have vendors providing different formats. Then it's maybe very difficult there to handle those one. So we really wanted to have a system that is flexible. So if the next vendors or the next organization is creating a new format, we want to be compatible. And we want something to be really robust. So sometimes we have data sources that are not compliant with their own sources, with their own schema, JSON or XML files, and so on. So it's not always pretty if you look carefully into it. And obviously, one of the main challenges that we wanted to solve is the fast lookup. And what we can say for the past, I would say, year, we actually solve those problems because we have working systems and it's completely operational. There are still, I would say, ongoing challenges and development that we need to tackle. One of them is the CPE fragmentation. So maybe some of you know the common platform enumerations. So basically, you have vendors and products associated to vulnerabilities. You have a huge database of CPE, which is somehow managed through NIST and other through the CVE programs. But you see over the time the CPE format change. You have organizations that get acquired, merged, and so on, and it's starting to create a huge mess there. So it's something that we are currently trying to solve to. In the software, we try to introduce organizations to bundle CPE vendor names and so on, and it's super important if afterwards you want to do notification and things like that. Another thing that we introduce in the tool, and it's still an ongoing process, but it's actually working, it's a coordinated vulnerability disclosure process. We integrate it into the tool. So in addition to do lookup, we are able to handle the CVE process from the reporting to the publications of the vulnerabilities. Another thing that we have seen in the past, I would say, year, is the vulnerability numbering. You have multiple identifiers through vulnerability sources, and that makes sense. But you actually need to have kind of correlation between those IDs, and you might need at some times to have allocation that are distributed among those, and I will come back to that. Another issue in scoring vulnerabilities, and that's really one we tackled for the past months. I will show you some example, because if you have to deal with vulnerability management, one of the biggest problems is like, what should I patch, when should I patch, and what are the priority of those different patching. So what is the current state? What do we import in the database? So I think we have a quite complete data sources. So we have more than 27 sources in Vulnerability-Lookup. So we actually get all the different sources for the CVE database. Actually, there's even 3 sources, which is interesting because you might have like differences. We import different things. Even GSD is stopped. You still have the historical data. We have all the GitHub advisories, PySec. Obviously, CSAF is a trend. I mean, a lot of vendors are supporting CSAF, and it's great. So we have a generic interface for this CSAF, and we are importing all the main vendors supporting CSAF. We integrate IoT specific vulnerability sources like Variot. We incorporate the JVM DB from the Japan friends, and some additional things like Tailscales and other sources. The system is actually growing. We have more and more sources. The thing that we do, we don't rewrite or revamp the different sources. We keep the original sources. So we can regenerate in any time the original sources of the vulnerabilities. And I think it's important because if you want to do research, you want to parse it with existing tool and so on, you have the existing data. It's actually growing. For the next release, we will include the Chinese vulnerability database into the systems. So if you know about sources that we don't have, just let us know and we will try to include that. By default, we export all the dumps. So if you are a security researcher, you want to access the dumps, they are all accessible on that link below. And if you have an instance running a vulnerability lookup, you can do exactly the same and even have things that you can even reproduce. So just a quick introduction, but I will not go deep into the design and implementation, how the system works. So the system works to scale with the capabilities of fast lookup. We have a huge key value store backends. It's called KVROX. It's part of the Apache Foundations. It's developed by a group of developers, mainly China, and they are really, really good. It's completely compatible to Redis, but it's on storage. So and the backend is using RocksDB. It's super fast and so on. So we basically have a very flexible system for integration. So you see on the right side, you have different feeders from the different sources. And from a user's perspective, you can use a UI, you can use the API, you can use RSS feed, Atom feed. I will come back to that later on. And then we have a part which is like streaming back sightings from different sources that we can automatically import into the system, and I will show you some example of that. So just some example of API, so if you want to play with it. So we have an extensive API, it's completely under OpenAPI, it's documented. You can do heavy pagination there, you can search between CPE and so on. We are big fan of RSS and Atom. Basically all the endpoints are RSS and Atom compatible, so you can basically monitor a specific product vendor name in RSS format, things like that. So you have a complete documentation for feed, so that's pretty easy. So that's, I think, the first step. You have a vulnerability database, you have all the data, all the sources, and you can actually use it. Now what you do, we want to get feedback from you, from the people that basically use the systems or even share information about vulnerability. So in Vulnerability-Lookup, we have, I would say, 4 different features to empower the users to get information and support what we do. For example, one of the features is bundles. So you can actually create a bundles of vulnerabilities, and that's quite, I think, very common for a lot of vulnerabilities. You might have Oracle doing a press release with a different information about vulnerabilities, and we actually aggregate those into a bundle. You can create your own bundle. I'm sure, for example, Aaron has a list of favorite vulnerabilities. He can create a bundle list with their own favorites one, and you can add comments, for example. It's classical things, but it's very important because nowadays vulnerabilities are not fixed. They evolve over time, especially regarding the proof of concept. Is there any remediations? Is the patching working? Is the patch complete? Stuff like that. So we basically support that. We have obviously tagging. We actually use all the taxonomies from this, and we have a very specific one called the vulnerability taxonomy to annotate that. Then more interesting things are popping up, sightings. So if one of you are actually talking on blue skies, on Mastodon about, or Fediverse, talking about the specific vulnerabilities, we can collect that information. So that means that someone has an interest in that vulnerabilities. So it could be a defender, but it could be, for example, a threat actor. So if you're on a Telegram channel from specific threat actors doing ransomware groups and so on, they very often talk about CVE, vulnerabilities and so on, and you can just cite that information. So it's really giving an insight about what's going on. So what are the kind of citing that you have in vulnerability lookup? You have basically things that are just seen. So if we see it in a specific infrastructures, but you have, for example, sightings for vulnerability that has been confirmed, exploited, and patched, and you have obviously the reverse if it's not confirmed, not exploited, and not patched. And you can actually have sources, and you can update that. So you can use existing feeders. So we have feeders for different kind of sources, but you can create your own to update the sightings. So what actually doing automatically? So we have already feeder existing. So we obviously feed sightings from social networks, Fediverse, Blue Skies, things like that, but come from private repository too. So for example, if you have a MISP instance, we actually do sightings from sharing communities. So we don't disclose the actual vulnerabilities, but we just disclose that a specific CVE is mentioned in an information sharing communities. Then you can automatically feed from different things like web page, GIST, RSS, Atom sources. We have specific ones for different sorting. So one is from Shadow Server. So Shadow Server has a very good honeypot network, so we can collect that information. And you can have like additional passive contribution from the community itself, adding sightings. I will show you how it's useful then. So what you can do there is actually scoring vulnerabilities. So first of all, and I think that's something that we really discovered when we started to actually implement it and use it, a lot of sightings appear with CVE IDs or other ID mentions even before it's published. The reason behind is people are actually sharing information about proof of concept, things that they are working on, even threat actors. Sometimes it's very strange because you have official advisories that take like weeks or even months before being published. So in the sightings on the interface, you can actually see this yellow bar there. It's a sighting that is mentioned of a CVE or an ID, but this one is not published. So it's another thing that you can even catch already information before it's actually from the NVD database or the database or different vendor sources. And that's something that you have to keep in mind. Sometimes people say, yeah, but it's hype and so on. Don't underestimate this kind of information. Sometimes you have very meaningful information there and you need to find out this one. And for example, I will show you some example of exploitation patterns. You have even platforms that are public or semi-public or even private that can give you a hint if a CV is actually exploited. So I'll take an example, and this one is for one of our past colleagues, which was like fan of Erlang. We have seen that, for example, one of the library for the OTP of Erlang was basically vulnerable. And you see on that one, you have a different point of view, like the patch release, the actually seen and discussions about it, and so on. So it's really giving you an insight about what's going on with specific vulnerabilities. And we do that for all vulnerabilities, all the different mentions. So that's really, really handy. Here, this one, sorry, but I took some recent ones. This one is Palo Alto Networks, cloud next generation firewalls. Yeah. And you see what you see there, it's actually the discussion about, but you have a continuous exploitations. And thanks to Shadow Server in this case, we actually collect their information, and you see that the continuous exploitation. So as a defender, it's really useful information. Is it still a threat? For example, I plug back my cloud next generation firewalls in the middle of that day. Is it really a huge risk? Things like that. I think you can think about it. Other things like another one, D-Link, it's classical product being exploited and so on. Especially those ones are very interesting because sometimes you have wave of those devices coming back. The reason behind, you have a stack of devices that need to be delivered to an SP. They are not patched. Older versions, they deploy those ones, and then you see a continuous exploitation and a peak then going with these exploitations. So another use case, and I think this one is one of the best use cases of if you go to one of the instances of vulnerability lookup there, it's what we call the most cited vulnerabilities. It's really giving you a sorted list of the vulnerabilities that you have to look at. And okay, no secret, but again, it was Ivanti for this one. You see that this vulnerability is something that people are actually talking about. You have a disclosing part and so on. So it's really important there. You can really spot the one that are on the radar. So other examples that are recent one, and I think this one is interesting regarding the citing versus, for example, the predictive aspect on being exploited. You see that some actually devices there are appearing and so on, but sometimes you have like, sometimes you talk about more vulnerabilities and so on. And if you look carefully, you have even vulnerabilities that where the sightings is really high, but there is no, for example, a lot of probability being exploited. No, you have to maybe discuss about the sources of calculation, those potential exploitability. And that's the case here is looking at the outliers. So the thing is, maybe you have to look at the one that are mentioned 1 or 2 times only on a very specific channel and specific sources, where there is no predictive model there, very low noise sources. For example, if you look at MISP or specific Telegram channels, then it's maybe vulnerability that you really have to take care, especially if you have one of those products in your network or infrastructures, maybe it's the one. So sometimes it's not the most cited vulnerabilities that are interesting, it's the one that are really outliers there. And what we can see is some of the predictive models rely on a lot of public threat intelligence feeds, but not actually from private sharing communities. So that's maybe something interesting for the futures of the different models there. Another thing which is really interesting too is really to monitor vulnerabilities prior to the public disclosures. You see on that one there, I don't know if they are published in the meantime, some maybe are not, but you see some that seems to be quite critical, like this VPN access for macOS clients. There are some mentions and so on, but it's not published. So why? What is the reason behind that? You have different things. It can be sometimes that the publication is there, but not in the NVD database. For example, the vendor published, but still it didn't send the information to be published on the CVE site, which could happen. Sometimes you have like a reference to a vulnerability they allocated, but it didn't took the time to publish it for whatever reason. So it's really interesting there to gather such kind of vulnerabilities to monitor. So now if we just summarize, we have vulnerability-lookup, we have 27 sources, we have no crowded information, sourcing of different parts. Now, can we do something with AI? And from our side, we're like, well, AI, it's tough. But we were like looking at more angles that we don't do at all. Things that we could solve with, when we say AI, it could be machine learning, could be natural language processing, and so on. And we found one first use case which is interesting, and this one is included into the system. It's scoring the vulnerability severity when you have no CVEs assigned or no CVE score actually assigned. And it's even going a bit above that. So, for example, the database that we have are pretty interesting because you have people that takes time to assign CVSS. It could be the vendors, it could be researchers, and so on. And you have a description associated to that. So that means a specific wording gives you an insight about the potential severity of it. And what we did is, we did a model. So everything is open source, and you can even regenerate it yourself. We actually use a dataset from Vulnerability-Lookup. We use a Roberta model. Maybe some of you know the Roberta model is basically a BERT model developed by Facebook. And this one is interesting because we were able to regenerate a model every 6 hours and predict the severity from just a vulnerability descriptions. So you can load the models, check the description. And it works with even pen test report. It doesn't need to be a vulnerability disclosure description. It could be a pen test report. You have a text, and you want to calculate the severity. Or you have complex one. We have seen a lot of complex description from the Linux kernel, but we have no clue about the actual severity of it, and we can calculate that. So we did some tests, and the accuracy is around 85%, which is not too bad. And the 15% remaining were interesting too, because these 15% are maybe vendors trying to trick the system. Not always, or maybe the model is not working properly, but it's very interesting. If you want to play with that, all the chain is open source. If you are having, like, I would say, traditional GPU card and so on, you can generate even your own models. And if you want to download the model is on Hugging Face under the CIRCL account, and you can actually use it. So it's the first model that we have is VL-AI, so Vulnerability-Lookup AI models, so for severity, and we plan to have new others, so we even set up an infrastructure for it, and it's something that you can actually use. The API is exposed for it, so you can even use a model without actually using the data from the vulnerabilities. Okay, so you see we did the step, huh? Collecting data, analyzing, scoring, evaluating, and so on. But now, if you have running an instance of vulnerability lookup and you have a CVD process, yeah, it's cool to do lookup, but I'm a producer of information, I'm a security researcher, I'm a vendor. I want to publish about those vulnerabilities. So that's where the second problem came to us. So from the early beginning of the platform, we were thinking of a model to identify those software instance of vulnerability lookup to act as a publisher. So what we decided to do is to create a kind of very lightweight authority called GCVE, which basically allocates numbering, prefix, to GNA. GNA are actually an instance of vulnerability lookup, or it could be an authority, an entity, and so on, publishing vulnerability autonomously. So there is no, I would say, string attached to be a GNA. You can have your own rules and so on. There are some very simple way to get a GNA values. And the GCVE is actually publishing what we call BCP, so it's basically document to describe how the directory works, or we sign the file, things like that. Or, for example, we do the publication process. And the most important aspect for us was all of the GNA are actually publishing a publication endpoint. And that publication endpoint, we have it in a vulnerability lookup. It's a way to have decentralized publications. So what you see there is actually different instances. Some are GNA, some are not. And you, when you run a vulnerability lookup instance, you fetch automatically the directory, and then you can decide from where you get the publications. So if one of them are deciding is interesting for you, for example, you really love the vulnerabilities from Siemens, and usually they are very well described, then you can add. And then you have another GNA that you don't really like, or you don't trust what they are doing, you don't select that as publication. So the GCV initiative that we are running is just a directory services to support distributed publications. The prefixes that we have for GCV are backward compatible. So we have prefixes for a majority of ID existing, like CVE, UVD, and many others. But if you want to run your own and be independent, or having a kind of backup plan if something goes wrong for publications, you can actually ask for a prefix there. So to conclude what we are working on, so we have actually an operational platform. It works. You can install it. You can download it. You can use a data set. You can play with everything that we have. You can become a GNA if you want to install our vulnerability lookup instance and publish it. Things that are complex that we are working on right now, it's ensuring source reliability. If you have more publishers, then it will be more complex to assure that. The second problem, and this one is, I think it was not solved, is a full text search. You'll say, but it's fine, full text search is easy. It's not in vulnerability escape, because the reason is the format of the different things have different weight on the different field. And right now we are working on that to ensure to have kind of consistent answer on full text search compared to a classical API search where you search for product and vendors. Because you might have product names inside the description, but not as a CPE attached, and that's super confusing. Then we are looking at integration of scoring model. Thanks, one of the authors of Vun Forecast is there. So what we plan to do is to integrate that into VLAI to basically have a model for forecasting. Still very experimental, but we are looking into it. Something I didn't mention in the features of vulnerability lookup, and I think this one is key, is notifications. I mean, if you are an SME, if you are a small cert, you really want to get latest information about vulnerability, specific product, and so on. So in vulnerability lookup, when you register in the instance, you can create notifications. So you can make around every vulnerability for event T, Pulse, VPN, whatever, and you will get it. Now, what we want to do is, right now it's email notifications. Okay, it's cool. We really want to go more into automation, so having webhooks, even for example, sending it to chat in Signal and others. So we do a lot of work there. So we do actually 2 to 3 releases per month. And if you have any idea and you want to contribute, you are more than welcome. So just to have a summary, the first link on top is basically the main website about vulnerability-lookup and all the information there. One of the public instances is obviously the one that we are running. So it's actually, this one is running the latest version of vulnerability-lookup, and you can really get all the information. If you go on the vulnerability-lookup organizations, we have already like 50 repositories with feeds, gatherings, backend software, and so on. So if you want to contribute and you like, it's Python-based, it's straightforward to contribute. For the one that are really AI freaks, and I don't know if Aaron is there, but people that really like to play with AI, the complete system with the vulnerability trainings from the creation of data set to the creation of the models, the calculation of the models, the publication of the models, and how to use it to infer and to use inference on that, it's public and open source too, so you can have some fun with it. Thank you very much.
If you have any questions for Alexandre, the microphones are to either side of the hall. Please visit them, ask your question.
Yeah, don't be shy.
Have you got any comments in there about remediation? So sometimes people run into trouble downloading a patch from a particular vendor or installing it, or I certainly find I want a lot more information about remediation than I can get from most sources.
Yeah, so remediation is very often produced not always by the vendors. Vendors say we install the patch and forget about it, or is incomplete information. So what we have seen is a lot of CIRCL, for example, produce their own report with a remediation aspect, which might be very different from the vendors. So right now, in Vulnerability-Lookup, you can create those commands with remediations and so on. But obviously, the next step is to combine those remediations and comment and feedback into something that is synchronized for publications too, so that you can get the actual remediations. The problem there, the remediation is really depending of the infrastructure of the user of the platforms. Another thing that is like something that we are looking into, but is still not in there, it's the detections rules, for example. We have a vulnerability, what are the actual detection rules associated? Right now we have CAPEX, CWEs, but we really want to go a bit further there, how to detect it, if it's exploited, and how we can remediate from these kind of exploitations. But it's a good question. Yeah.
If we have detection signatures, is there a way to link them in some way to the rest of that infrastructure? So like, say I have a detection signature for a particular CVE, and I want you to make users aware that there's some GitHub repo with that YAR signature or whatever.
Yeah, you can already do it in the addition of the links and so on. But at some point, you need to have like those kind of voting for remediation to say this remediation is actually working and so on.
Of course.
Yeah. Thank you.
I wanted to ask if you have considered cooperation with Taranis AI, because there seems to be a partial overlap. Taranis is a tool that is also used for collecting information about vulnerabilities and publishing security advisories towards the constituency of the CIRCL. And Vulnerability-Lookup can work well in cooperation with Taranis and share the resources as well as the AI models.
Very good point, and indeed we work with Taranis AI, especially for the MISP integrations. But obviously the next step would be an integration with Vulnerability-Lookup. So like that's the disseminations toward the constituent through Taranis AI would work there. So yeah, indeed it's in the pipe. Thank you.
So with the CVE lookup, you ran into the trouble of a hard limit in the amount of queries. I would imagine that this is even more resource intensive.
Yeah.
You foresee that this can scale up for the next 10 years?
Yeah, so the design of it is actually to have distributed key value store. So that means we can actually store on a cluster with multiple machines. So the design that we did, and especially that is something very important, we don't actually touch or parse the original source code, source data. So we actually have key values there that can be even sharded among different systems and so on. So it's actually the idea. Yeah.
Yeah, with vulnerability sightings, often when there's a new hot vulnerability that's making news, there are a lot of fake proof of concepts and clickbaits and just no new information, just somebody's recycling it. Is there some reputation that you attach to the sources? Or how do you
Really not, and that's exactly the next steps is source reliability assessment that we are working on. So one of the ideas is to have the capabilities to combine some specific sources and saying those one have a higher weight compared to the others. But that's exactly what we are working on. It's tough because the thing is you still have to have an assessment from a security analyst if you have a POC and so on. On the other hand, the POC usually lifetime that are fake is very short because you have some people that are like saying, oh, this one is fake or incorrect.
Thank you for your sharing. I have two questions about your vulnerability database source, feed source. One is, will you include the EUVD in your platform in feature? And second is, will the platform accept the external or additional vulnerability source from specific company, like a security page, the company that has a security release page?
Yeah, so very good point. So EUVD, yes, and the side note of it is actually the backend of EUVD is Vulnerability-Lookup. So we have strong tie between the two. And right now we are even working on the matrix table of the EUVD ID with the other IDs that will be incorporated in the next versions of Vulnerability-Lookup. Regarding the vendors, this one is a challenging one. So what we do is actually, if I'm going back to the different sources, CSAF is easy because you have a lot of vendors going for CSAF. But some vendors are still producing RSS feeds, CSV files, and stuff like that. So I will urge vendors to actually use a standard. And if they use CSAF, they will get in Vulnerability-Lookup like in the same day. So that would be an initiative. But if you know about other sources that we should parse and incorporate, for example, Tailscale is one of those because this one is an RSS feed, unfortunately. But if you know other vendors that provide some more structured page that we can parse, just create an issue and then we will look at it. Thank you. Thank you.